Alright, I just wanted to preface this by saying sorry about this thing we have here at the bottom of the screen. I didn't realize that was there until after I was recording and looking at the recording. So sorry about that, and feel free to follow me on YouTube or Twitter if you feel like you must. So yeah, let's get right into it. Hello, it's Gabe Platty, and today we're going to be looking at this equation and figuring out how much products we get with 20 grams of sodium hydroxide. So first we want to start by balancing this equation. So as we can see right over here we have 2 sodiums, and over here we only have 1. So to fix that, we're going to want to put a 2 over here. That'll also help us. It'll give us 2 oxygens and 2 hydrogens, which also helps balance it out over here as we have 2 hydrogens. And then we also have 1, 2, 3, 4 oxygens, and then having 2 oxygens here, 2 oxygens here, the whole thing is balanced. And that's our final balanced equation. Alright, so now that we got our equation balanced, we're going to be figuring out how many molecules of each of these we actually have given our 20 grams of sodium hydroxide. So first what we're going to do is we're going to figure out the molecular weight of 1 molecule or 1 mole of sodium hydroxide. So first we're going to take a look at the sodium. Our sodium has a molecular weight of 22.990 grams, or AMU. And then we're going to add that with 15.999, which is the molecular weight of oxygen. And finally 1.088, which is the weight of hydrogen. We add those all together and we get 40.07 grams per molecule of sodium hydroxide. So now that we know that, we can use it to figure out how many molecules of sodium hydroxide we actually have given that 20 grams. So we're going to put our 20 grams here over the 1 molecule. We're going to multiply that by our 1 molecule over the 40.07 grams and multiply that out. We get 0.449039 molecules of sodium hydroxide. Now that we know this, we can take a look up here and see that for every 2 grams of sodium hydroxide, we have 1, or every 2 molecules of sodium hydroxide, we have 1 molecule of each of these other compounds. So what we did was we multiplied this 0.499 by 2 and by the coefficients of each of these, and this is what we ended up with. And now we can use this to finally solve and figure out how much of each of these we have left. Alright, so now that we got this equation done, we're going to try to figure out how much of each product we have left. So we're going to do this by figuring out the weight of each of these compounds, and then we're going to be multiplying that by our 0.499 molecules to get our final answers. So we have 2 sodium here, so we're going to start that by doing 2 multiplied by the weight of sodium, which is 22.99. Got that, and then we're going to add that to the weight of carbon, which is 12.01. And finally add that to the weight of oxygen, which again is 1599. And as you can see, we have 3 molecules of oxygen, so we're going to multiply by 3, and then the 15.999, and we're going to multiply that out on the calculator, and that gives us 105 points. It's 105.987. And that is how much 1 molecule of this sodium carbonate will weigh. Now what we do from here is we will take 1 over our 0.499, and we will multiply that by our weight, which is 105.987 over 1. These ones cancel each other out, and that leaves us with, put that into the calculator real quick, that leaves us with 52.888 grams of the sodium carbonate and A2CO3. So that's how much of the sodium carbonate we have, and now we're gonna figure out the weight of water. So hydrogen, we have 2 hydrogens, and that has a weight of 1.008. Then we're going to add that to our 1 oxygen, which is 15.999. Multiply that out, or we're going to add that together, and that's going to give us 18.015 grams per molecule of H2O. So now we're going to do the same thing here. We're going to do the 1 over 0.499, multiply that by 18.015 over 1, multiply that out, and it gives us 8.989 grams of H2O. Alright, and that gives us our final answers of 52.888 grams of the sodium carbonate and 8.989 grams of water.